here, they give you a table. They give you f of 3, which is useful because it's not in the table. And they give you f prime here. And they want f double prime. You can ignore this sign of 2 for the moment. You can just pretend like that's x for the moment because you need to find f double prime of x. So basically you need to take the derivative of this.
Okay.
And this is product rule. So as a student, you have to be able to do those things that I just mentioned, in a short amount of time, and be able to interpret all that. So what is the product rule derivative here of this thing?
So what's 1 times negative sine e to the x? No. 1.
Well, you can't take both. You gotta give me one of uv prime plus vu prime. You either gotta keep yeah.
So x times negative sine e to the x, and then
times e to the x, because there's a chain rule there.
How do you know when there's a chain rule?
You have to keep going until you've exhausted everything, like all the way inside.
Okay, and then it's plus cosine. Yeah.
Yes. Okay. Is that okay? I mean, that's
yeah.
All right. So sine of 2, that's the x value. And that's where your instructor, I assume this is a calculator question.
Yeah, it was a calculator.
Okay, so this is two radians, by the way, in case you're not sure which mode you're supposed to be in.
Okay.
So that value sine 2 goes wherever you see an x. So let me calculate that, because it's a little weird when you do it like that. 0.9093. So sine of 2 is 0.9093, and that's really what's going in for x. So it's 0.9093 times minus sine e 0.9093 e 0.9093 plus cosine e 0.9093.
Why 0.9093?
That's the sine of 2.
Oh.
Now, if you want, I can show you on a calculator on this Zoom session how to do this faster if you think you're going to need a problem like this.
Oh, it's just the end-derived thing, isn't it?
What I was going to do is have you store the value to x in your calculator, do a sine 2, store x, and then you just write this expression in the next line.
Can't you use end-derive? I think that's what we did during class.
You can. That's not the best approach.
Okay.
It does work, but that's not you definitely don't want to use that for this problem. Okay. I was just trying to show you a faster way to like calculate it, but it's not that important. Is this part clear though? Can we go on to next one?
So you're just plugging in for x sine of 2.
Yeah, it just gets cumbersome when you put sine 2 everywhere because you're gonna have a lot of parentheses.
Yeah. That makes sense.
Okay. Part B.
Wait, and then you just find the value?
Yeah, it's a number.
Okay.
Do you need the number? Like, do I?
No, I have the number already. We went over that one.
Okay. You can tell, like, probably tell that, like, as you get more further up you go in math, the less like we actually like do the final answer, because it's not there's all the intermediate stuff that's more critical. Okay, so they're telling you what h of x is. They're telling you h of x is this, and they want h prime of a number, but really of x. So h prime of x. And this kind of relates to that question you just asked me, which is like, when do you stop taking the derivative? Like, it's kind of like factoring. Like, you're done when you know you're done. So you got to do a bunch of them to like get comfortable with like where the endpoint is.
Yeah.
So here you got g, f, and then 2x. So it's g prime of, and you keep the inside. The inside is f of 2x times, you have to take the derivative of the next thing. The next thing is f.
Mm-hmm.
So it's f prime, keep the inside, times the derivative of 2x is
2.
2. That mapping has to be very clear for you, like something that you can do.
Yeah, that makes
Okay, now they give you a number. They tell you x is 1.5. So you just put that in wherever you see. So that's f of 2 times 1.5. I would personally like to see you be able to like multiply this as you go. So like, f of 3 like that, and then f prime of 3, just to reduce the amount of writing you have to do on this. But that's just my preference. So we need to go find f of 3. F of 3 is 2. That's given.
given. Yeah.
Okay, so this becomes g prime of 2 times f prime of 3, which I don't know if that's given. No, it is. It is. So f prime of x is up here. So let me snip that. Let me snip that again. This is a very complicated in the sense that there's a lot of like going back and looking for stuff.
Yeah.
So your f prime of 3 is this over here. It's 3 cosine e to the third. So that's this over here.
So you're just plugging in your 3 again. Okay.
There. G prime of 2, you got to go back to the table. Your G prime of 2, you go back to the table, you find 2, and then it's either 0 or -3. -3 is the G prime value. So that's how you get it on the table.
Okay.
Is that clear?
Yeah.
Okay. And then there's a part C. Oh boy. Okay.
I think there's a part D too.
Yeah, part D. I keep going. So okay. So here, I guess you are going to get inverse stuff at -2. All right. So we need the point. So we know the point. We know that x is -2. So we got to go back to our table. This is for G. Okay, and we're looking at where is the output -2. Sorry, where's the output -2? So right here, and the input is 3. So it's a switch. It's a swap because it's the inverse. Like normally the ordered pair is 3, -2, but because we're looking at the G inverse of x, you switch the two of them. So y becomes 3.
Okay.
And to me that doesn't feel clear, but
It's a little weird.
it's and you get this from the table. This is actually the G of x value. This is really the x value, but because it's G inverse, they're flipped or swapped. Is that okay?
Yeah, that's fine.
Okay, now this is more annoying. You're taking G inverse of x prime derivative. Actually, that's not written right. Prime equals 1 over G prime of x. So when you want the derivative at the inverse, you have to get G prime of x, and then it's 1 over that.
Okay, that's a
The definition.
yeah, the definition.
You have to know that. So G prime, now we got to go find G prime. Where's G prime? G prime. Oh, okay. So we got it. Okay. So G prime of that is -4. Oh, no, I'm sorry.
G prime
Yes,
of,
yes. Because so are you? Yeah, it's really weird. Let me.
wait, so what are we looking for? G prime of what?
Of well, this is again where it's backwards. Let me snip this in. I'm just trying to snip in the table. Let me
Yeah.
grab it again. So your your x is really 3. Like you're looking at this column,
Right.
even though you might think x is -2.
So basically what you look for, so they give you x is -2. So then you look where you see -2 on the table
as y,
as y.
which is right
Okay.
here, which tells you that this is that's the column you're using.
Okay.
And that's how we got the ordered pair.
Right. -2, 3.
Yes.
But
And then
then
that's where we get the slope,
what do you mean the slope?
g prime.
But we haven't calculated the slope yet.
But it's right there. It's -4. This becomes 1 over -4.
Oh, I see. Gotcha.
This is very confusing, even for me. Meaning like I have to look this up every time, and oh yeah, it's flipped, and oh yeah, it's that one, and you got to but this is not a critical part of calculus, but it may be an important part of this test.
Yeah. Okay, I kind of get it. Like it's just like the opposite of what you would think.
Yeah. So let's look at this table, and let me go through. It's my understanding you want to understand this. So
yeah.
So let's try another one here. And let me try and talk you through the steps. Okay, so let's say we want G inverse of X when X equals 4.
Okay.
So what this means, what this implies, is that G of X is actually 4.
So you're looking at the -1 column, so it's -2?
Yes, so no. So y, this tells you the y value. So y is -1 because these are flipped or swapped for inverse.
And then if you want the G prime of X value, it would be -2.
That's right. And then you would write your equation here of y minus -1 equals -2 x minus 4.
Got it. Okay, that makes a lot more sense.
Yes. So that's the key thing. We had that in your textbook problem also. Like you have to look, you have to find that output point.
Okay.
Okay. Part D. Is this really representative? Because this is a lot of, this is a lot of effort here.
He said that
we're 15 minutes in. This is.
No, yeah, he said he wouldn't include like all of these parts, but like he was like, this is a good problem. So
Okay, let me try to, maybe you already know this, but when I hear that, what I think it means is that there's elements of this problem that you're going to be tested on.
Yeah, exactly.
And when I look at this, you're going to be tested on an implicit derivative, and maybe more generally like power rule, chain rule, but like not the synthesis of all of this. So would you like us to go through this? And I'm okay to do it. You just let me know.
I think let's.
All right, let's do it. So this right here, this first one, we got to take derivative of this. So I know I don't read these things, but it's just dy dx, implicit derivative. So this is power rule 2 f of x, and then it would be to the power of 1. Okay, we don't write that, times derivative of the inside function is f prime of x plus g prime of x. Okay. Now, now just as an aside here, let's just say this is g of y. It would be g prime of y times dy dx. But because it's a function of x, that there is no implicit derivative of that.
Because it's an x, you mean?
Yes, because it's an x, you're doing. Now, x times y is product rule. Okay.
So x, y,
or y prime. I think you like y prime.
Yeah.
Okay, x y prime plus
y.
Yeah. Okay.
1, 0.
Okay. Now it wants you to solve for y prime. So you have a choice. You can put the numbers in, or you can solve for y prime and then put the numbers in. What do you want to do here? What do you think you would do on the exam?
What was the first? Plug them in or what?
Plug in the numbers for X and Y, and then see, like, move some things around.
No, I think move things around first.
Okay. So Y prime is 2 f of X, f prime of X plus G prime of X minus Y all over X.
How did you do that?
Just so you can do this. I'm just skipping the step of moving and dividing because it's a lot of writing.
Well, so you
just subtract the Y over and then divide by X.
What happened to the Y? Oh, you moved it over to the other side. I see.
Yeah.
So now you plug in the 3 and the 2. What was it?
The
3,
1, 3 and 1. So X is 3. So this is 2 times f of 3, f prime of 3 plus G prime of 3 minus
1
all over 3. So now we got to go look for these values.
Okay, that's where the table comes in again.
Yeah, some of them. So f of 3 is 2. So this first one is 2. 2 times 2. If prime of 3, if you remember, was 3 cosine e cubed. And G prime of 3 comes from the table. That was minus 4 minus 1 all over 3.
And then you just plug that into the calculator.
Yes.
Okay.
Okay. Are we ready to go on to wait? Is there a part? Is there a part F? Part E?
I hope not.
Okay. I mean, this is similar, so this is good. I mean, there's more stuff here. Okay. Okay. Go. Let f be an increasing function. F of 0 equals 2. The derivative of f is given by f prime of x equals that. Find the second derivative of negative 2. So you have to find a second derivative, which means you have to find a first derivative. But they already give you the first derivative, so you're already kind of all the way there. So f double prime of x is, what's the derivative of sine?
Cosine.
Cosine, keep the inside function, times the derivative of pi times x. It's pi.
Yes, pi.
Plus, what's the derivative of x squared? 2x, and you're good. So now f double prime of negative 2 equals cosine negative 2 pi times pi plus 2 times negative 2. So I just put that value in for x and brought the pi over.
Oh, okay.
Now, I know you've been a really good student last day or two, right? You've been studying up on your unit circle. 0. And if I go around, that's 2 pi. But if I go backwards, that's minus 2 pi. So what is the x value? Because cosine is x value. What's the x value right there on the unit circle?
1.
1. So this whole thing is 1 times pi minus 4. So your answer is pi minus 4.
Oh, okay.
If I were to guess, your instructor will give you a value on the unit circle that's on one of these nice points. So you just, at least those need to
Right.
do that.
I can do that.
Yes. But that's, it's me. It's Matthew guessing. Matthew
Yeah.
doesn't have infinite knowledge. So please take that
lightly.
Lightly, yes. If I knew, I would tell you, but I don't know. All right. So that's part A. Any questions on that?
No, that makes sense.
All right. Part B. Part B says write an equation to the line the graph of y equals 1 over f of x at x equals 0. So the mistake here is to not realize that, like, this is a very different problem. 1 over f of x is its own function. Okay. And in fact, it's like, it's actually kind of a rewrite here. It's like saying f of x to the minus 1 power, not inverse, to the minus 1 power.
Okay.
So it's a power rule followed by a chain rule. So your y prime here is negative
1 f of x
to the minus 2 power times, what's the derivative of the inside function? F prime of x.
Yeah.
So it's kind of like d dx of 1 over x, it ends up being minus 1 over x squared when you do that. And because this right here, this part rewritten is negative 1 over f of x all squared.
Okay.
Okay, so now we just got to go find some values. We got to go find what happens at 0.
That's in the table again.
So negative 1 over f of 0. Now, sometimes you can put the squared here. I would probably keep it out here. F prime of, I'm sorry, 0. No table this time. That they better give you these values. They do. They tell you f of
Wait,
0.
it's not in the table?
No table on this one. This is a new problem. And they tell you f prime of x.
Oh, they just tell you in the instructions, you mean?
They just give you these functions that I'm writing.
Oh, okay.
So they do give you enough. And that's kind of a check. Like, let's say you wrote f of, I don't know, 2 here. You don't know f of 2. So like, if you don't know it or you can't go and find it, you made a mistake.
Okay.
That's a little bit. So f of 0 is 2. And then f prime of 0 comes from putting 0 in here. Sine of pi times 0 plus 0 squared plus 3. So this is sine of 0 on your unit circle. Again, that's right there. That's the y value, which is 0. So it equals 3. So f prime of 0 is 3.
Okay.
Okay, so it becomes like negative 3/4.
Right. Okay.
Jake,
But that's
assume you-
your, is that what they're asking you to find?
Oh
So
no.
y
Well,
prime?
that's part of it. Sorry, I always
Okay.
forget there's more. Wait, there's more. So you need the point. That's the slope. You need the point. The point when x is 0. Okay, your point. If you go back, it's y equals 1 over f of x. So it's 1 over f of 0. F of 0 was given.
But do they wait? So the f of 0, because they ask you to evaluate it at x equals 0?
Yeah, this is what they're giving you. So
Right.
so that's your y value.
They
Like,
stay at x equals 0 though?
yes. Let me scroll up here, right here.
Okay.
It's all there. It's just it's so very subtle. So,
Yeah.
okay, so you got that point. Y minus 1/2 equals negative 3/4 x minus 0.
Okay. So that's the tangent line equation.
Yes, they're asking for tangent line.
Okay.
All right. Let's see. Why did they give you a 10,000 word limit?
I don't know.
It's a long essay.
I know.
All right. So part C, find g prime of 2. Let's do a small rewrite here. And I do I do recommend spending the time to rewrite this. It's f of parentheses 3x squared plus 4 all to the 1/2 power. And the reason is because you're going to do a derivative of this g of x. So let me just make that clear here.
So it's
go ahead.
Oh, so you're okay. F prime 1/2.
Oh, you got to keep it first.
Okay, 3x squared plus 4 to 1/2.
What just curious here, like somehow this isn't clear to a lot of students. And I can't put myself back in your position. It's like you got to keep, like, you do the outside, but then you always keep it. But like a lot of students try to like take the derivative again. Any insight
Well,
into why?
are we doing chain rule right now?
Yes.
Oh, okay. I thought we were just taking the derivative.
You are, but it's always chain rule. Like it's kind of a lie, because when you start doing power rule, the derivative of the inside function x is 1, so you never multiply by 1.
Yeah, I don't
Like,
know.
okay. Well, anyway, so now we got to take the
So now
derivatives.
you're okay. So now it's 1/2 3x squared plus 4. Did you just do 1/2 minus 1, right?
Yes,
Yep.
exactly.
Okay.
Yep.
And then times 6x.
Perfect. Okay. So this is good, but now you got to evaluate it at 2.
So
You
now
gotta
you
put
plug
2
it
in for
in.
x. Yeah.
Okay.
And I think that's what makes these so challenging is like, there's a lot going on. So it's 3 times 2 squared. So that's
2
4 times
squared
3,
4, so 12.
16.
Yeah.
Square root of 16 is 4. Okay. Now, this is where you got to be that beyond, even better student. You got to realize like you just did this 3x squared plus 4 to the minus 1/2. So that's 4,
But
one
it's the
half.
minus 1/2, not just the 1/2.
Right. So it's 1/2 times 1 over square root of 4, which is 1/2.
Yes. Okay.
I'm sorry, 1 over 4. That's yeah. Because this really becomes 1
Because
over
it's
the
like the
square root of 16
Yeah. Okay. And then
times
6 times 2, so 12.
12. Yeah. So the more you can do that, the better. So we got to go find f prime of 4. Let me go back and look here. I know you don't have this as quickly as I can get it here. So f prime of 4 is sine of pi times 4 pi plus 4 squared plus 3. So again, 4 pi, you go around the unit circle once, that's 2 pi, go around the unit circle again, you're
So
right
it's
there.
1.
So it's 1. That's the y value though.
No, it's 0.
Yep, 0 plus 16 plus 3. So that's 19. So all of that is 19. And then this stuff over here on the right, yeah, it looks like it's 3/2.
It's 6 times 1/4, right?
Yes,
Okay.
57 over 2.
So is that like, what is that? Is that your slope, or is that?
This one just wanted, we do so much, it just wanted the derivative at a point.
Okay. Okay.
Okay, part D is this horrible inverse again. Okay. Let h be the inverse function of f, find h prime of 2. Okay. Okay, so this is telling you, let h be the inverse function. So we're trying h inverse of x. Okay. I'm sorry. The notation isn't really that important. Let's not focus on the notation.
Okay.
This from our previous point, we know that x equals 2, but really that's like your y value. So that means that you're really looking for f, like this corresponds to the y value of f. So the output, maybe that's a better way of putting it.
Okay.
And so let me, and again, you only have like I can't, this is one of those things, like if you can get this as a student, you're gonna be really way far ahead in like college and all your other classes too. Like this is all the information you have. So where does the 2 appear? Right there.
Mm-hmm.
So that means the other value that goes with it is y. Y is 0.
Okay.
Okay. So then the slope is 1 over f prime of x.
That's just the definition,
And
right?
here's your derivative. Yeah. So it's that, but we got to pick the value. The value is going to be
2.
at it's, well, again, like this it's whatever the x value is here. So it's at 0 because this is the x of the original.
Yeah.
So that's your x value. You have to evaluate this at 0.
But aren't you trying to find h prime? Oh, but it's
It's the inverse, so it's flipped.
Okay. That's so weird. Okay. So it's 1 over sine pi 0, right?
Plus 0 squared plus 3.
So it's 1/3.
Yes. And it didn't ask for the tangent line, but you would need those points for the tangent line.
Oh, wow. Okay. So it's 0 because it's like the inverse function of f, not f prime, right?
It's
Like,
okay. This 2 corresponds, like these correspond to the inverse. The original is x equals 0, y equals 2. And because f prime of x is the original, or f of x is the original, that's why I use that x value.
aren't you trying to find f prime of x though?
Yes.
1/f prime of x?
Yes. And that's why I use the original x value, not the inverse x value.
So what would be the inverse x value?
This is the inverse. It ends up being h. But maybe the notation is important here. Do you want me to go through the notation correctly?
Yeah.
Okay, so f of x is a function. X equals 0, f of 0, which is y, because y equals f of x, is 2. That's given. That's all given. H is f inverse of x. F inverse of 2 equals 0. So here, x is 2 and y is 0.
Okay.
Just the flip of those. The f inverse of x prime, which is the same as h prime, because you're just taking the derivative of both of these, is equal to 1 over f prime of x.
Okay.
So it's 1 over this sine pi x plus x squared plus 3.
Right.
And you have to use the original values because you're dealing with f. That's why you put this 0 in.
So it's the flip of the inverse.
Yeah. Yeah. If that's how you want to remember it, I don't want to say yay or nay. I just.
Well, right? Because your y in your inverse is 0 and your x in your original is 0.
Yes. Yes.
Okay.
Flip sometimes means reciprocal, so just that's why I didn't. Yeah,
No, not
so
like
yeah.
flip,
So yeah.
but like
Yes.
just, you know what I mean.
Yeah. So like to me, swap. But I'm not trying to get hung up on the words, but just that it's.
Okay. All right.
Okay. Can we move on to 3 now?
Yes.
3 looks incomplete. Do you need us to do it like fully for credit or?
I don't think I put any answers in for 3.
Yeah, that's what I meant. It looks like it's so I can be extra careful if like this is for a grade to make sure you know.
Oh no, if as long as you like click, exit, it'll save. It won't like submit or anything like that.
Okay. Why is that? Okay. So first question here is an implicit derivative. Whenever you see x and y's on the same side, it's an implicit derivative.
Okay.
So this is where we're starting. So the derivative of y squared is 2y y prime.
Yes.
Minus.
Minus.
Now I'm going to do this with parentheses here. So it's x squared y prime plus 2x y
Y.
equals 0. The reason I put the parentheses here is it's very easy to forget to distribute both. Now, because they're giving you the answer here, you probably would have figured it out. But just it's one of those things that be very cautious with because there's a lot going on in the exam.
Right.
So you're just solving for y prime. Yeah, so I'm going to move this to the other side. So it's 2y y prime minus x squared y prime equals 2xy. And then you factor out.
The y prime. Yeah.
Yeah, so we got the move, the factor, and then the divide step.
It's y prime 2y minus x squared equals 2xy, and then divide by the 2y minus x squared.
Yes. Okay.
Okay.
Great. So that is part A. I don't know how you show that in the box, but that's probably why you didn't do it. submit a picture. I guess you can do that. Oh, in college, maybe you're already doing this. It's actually pretty common. They're using lots of different tools now to like have you submit your work.
Yeah, we do the math Excel right now.
Yeah, so they give you, they you expect this. So tangent line, need a slope, need a point. So they give you a point, okay, and the slope comes from the derivative. Okay, so you're already there. Y prime equals 2. Put these values in for x and y. 2 times 1 times 3 over 2 times 3 minus 1 squared. So you get like 6/5 when you're done.
Okay.
And then you write your equation. Y minus 3 equals 6/5
That's x minus 1.
x minus 1.
Oh, that's simple. Okay.
C looks to be more complicated. Let's see what we got here. Show that there's a point. All right, show that there's a point P with x coordinate 0 at which the tangent line to the curve at P is horizontal. Okay, so we know that horizontal tangents occur when the numerator of y prime equals 0.
Okay.
So you go back here, you find your, well, I guess we can go to here. So this one's different because we're setting 2xy equal to 0. So it's 0 when either x is 0 or y is 0 or both.
Okay.
X equals 0 or y equals 0 or both. Okay, but when they're both 0, okay, the bottom is also 0. That's bad too. So it's just one or the other.
How do you know which one to do?
Well, it's telling you that x coordinate is 0, saying that must be true.
Okay.
So you go back to the original. And say, okay, x is 0. Let's go back to the original. I'll snip it in again. Oh, I didn't even notice this. This is important here too. The domain of the original function. The domain of the original function is for y greater than 0. So y can never be 0.
Okay.
Okay. So x is 0. So y squared minus 0 squared y equals
so
6.
that's showing that it could never be 0. I see.
Yeah, so you solve this, y squared equals 6. Y equals plus or minus the square root of 6, but y has to be greater than 0. So that means that it must be the positive square root of 6, and x equals 0, and y equals that. So that's your.
So is it asking? It's asking for a point. Is that what it's asking for?
Yes. Let's go back. Is that oftentimes there's so much going on here that you got to be like,
what show there is a point P. Okay.
Yeah, find the y coordinate P. So show it. Kind of did. Lot here. Lot.
Okay. Is that the last part on that one?
Nope.
Oh wow.
There's part D.
There's more.
There's more. Okay. Find the value of d squared y dx squared at point P found in part C. So we found the point. The point was 0, square root of 6. Okay. But we don't have the second derivative. It would have been good to know the second derivative was coming up because there's a step right here. Let me snip this. Actually, let me just grab this line. So this line right here. See, whenever you know you're going to do a second derivative, I break it into two steps. Over here, you solve for y prime. We've already done that. Okay, or that's already given. So that's not super difficult, but like you don't normally have it in the original problem. They tell you that y prime equals 2xy over 2y minus x squared. But over here, you have to take a second derivative, okay? And it's got a lot of, it ends up having a lot of product rules in it.
So is it like 2y
Y double,
prime? Yeah, prime
double
prime.
prime, yep.
And
Plus,
then minus,
well,
oh,
you got to take the rid of this.
oh my God, I forgot.
Yeah,
So then
product rule.
so that's y prime.
It's 2y prime because it's the derivative of that. Because
Times
derivative
y prime
times y prime, so you end up getting a y prime squared. Okay, but now you're on to this one. Okay,
minus, okay, so then it's x squared y double prime,
okay,
and then 2x y prime
okay, minus,
minus 2x y prime, right? 2x y prime,
sure, yep,
and then plus yeah, because the x goes away.
yes. That was just a lot of algebra.
Wait, why do you keep the 2? Wouldn't it be just x times y prime? Wouldn't it just be y on the last one?
You're talking about this right here. So the derivative of
2x
y
times
is
y
y prime.
prime. Yeah.
Okay, but then the derivative of 2x is 2. Keep the y.
Oh, right. Yes.
And this is a really good problem. It, like your instructor says, like it's really, there's lots of good things here now. I don't think you'll get anything this complicated, but there's a lot going on here. So 2y double prime plus 2y prime squared, okay, minus x squared y double prime minus 2xy prime minus 2xy prime minus 2y equals 0. These are like terms, so that's gonna help out here. But we end up having to, like, these are on the one side, and then we got to move this other stuff over.
Okay.
So this is minus 4xy prime, so it becomes 4xy prime. You add the 2y, then you subtract the 2y prime squared. That's why you need that y prime up here.
Okay.
And then you have this 2y y double prime minus x squared y double prime.
Right.
So imagine factoring it out and dividing. Y double prime equals, I have the advantage of copy and paste here. Okay, so it's that over 2y minus x squared. But this right here, your y prime, is the 2xy over 2y minus x squared. And they actually want you to put that back in.
Because that was that's given, right? The y prime is.
Yes, or you would have solved for it as part of doing this. So instead of this, get this, it goes right in there. 2xy, 2y minus x squared.
You have to simplify that.
Well, not for me, but yeah, I mean, maybe.
I mean, how do you even simplify that?
It's not great. I mean, you have to multiply top and bottom by like.
I think he said that this one was too. I think he said D was too complicated or whatever.
Yeah. Well, he doesn't want to grade it either. It's a lot of effort to go in and try to figure out,
where the mistake was.
Where the mistake was, and there's various like different forms of this. Like, let's say you moved y double prime to the right, everything's negated, and the negative could have been on the top or the bottom. These are horrible to grade. I actually am surprised they give them to you because of that. But
yeah,
you could bring that up to your instructor and say, these are too hard to grade, so just exclude them from the test.
Don't do that.
Okay, so that does take us to the end of number 3. Do you want us to look at any other questions in here?
Not on that one. I did have one in the book, but probably don't have enough time for it.
So there was like 82 or something that we did yesterday, 81. That's kind of like this. Do you want us to look at that again?
We did 81 yesterday, I think.
Yeah. Do you want us to do another one?
Yeah, what he was saying that was the particle motion one. 70 was good. But something like that might be on there.
Waiting for it to load here. Come on. Yeah, we can look at particle. We'll do as much as we can here on 70.
And I have the answers in the back. So
all right. the position at time t greater than 0, moving along the s-axis, is give parametric equations that can be used to simulate the motion of the particle. Okay. Why? I guess I don't follow. Maybe they just want you to find v of t here,
Maybe, probably.
and then maybe a of t. I'm not sure what else, because usually particle motion refers to velocity and acceleration.
Well, that's what he said in
Okay.
class, velocity and acceleration.
Well, that's good. We got let down. So this 10 comes with it. What's the derivative of cosine?
Negative sign.
Negative sign. Okay. Keep the inside function. And
then
then multiply by the derivative of t plus pi over 4, which is?
So is t just 1 plus
Just 1, because the
pi over 4? Yeah, it goes away.
okay. And it's worth simplifying. So you bring the negative out times 1. So this becomes negative 10 sine t plus pi over 4. Okay. Now we'll find the acceleration. Acceleration is yet another derivative. So negative 10.
So it's the derivative of the velocity, right?
Yes.
Okay.
Another derivative. Cosine t plus pi over 4 and times 1 again. So you keep that minus 10 cosine t plus pi over 4. So you simplify when you think you might use them.
Right.
And that's there. So part B is, snip this in, particle's initial position. So you gotta make sure you're using the right function. Which one is it? It's the one that's given. So like sometimes students, I'm not saying you do this, but you can do some of these problems even if you don't really understand the calculus. You just have to be like, oh yeah, original function. I can do that. S of 0 equals 10 cosine 0 plus
0. Yeah. Okay.
Okay, now where is that on your unit circle? So pi over 4 is right there. Cosine is the x value.
Oh, so you do need to know those ones.
Well, for this one you do.
Yeah.
So 5 square root 2.
Okay.
Okay. And let me see if I can talk through part C here. What points reached by the particle are farthest to the left and right of the origin? Let me go grab this again. So if you were to graph this, which is what is needed here, a normal cosine starts, just imagine this is 10 and minus 10. It starts high, goes low, comes down, goes back up.
Right.
Okay. The minus pi over 4 just shifts it left, so it's going to look like that. Okay. So it's just asking for where is this point and where is this point?
So 10 and negative 10?
No, the t value in this case. So like normally unit circle again, where does cosine, it's its biggest value at 2 pi, right? If you go all the way around at 2 pi. So how do you get to 2 pi? So it's when t is 7 pi over 4, that gets you back to 1. And then when is it lowest? Because 7 pi over 4 plus pi over 4 gets you back to 2 pi. And then when is its lowest? It's at negative 1. So or at pi. So at 3 pi over 4.
So it's 3 pi over 4 plus pi over 4.
Well, they're two. Yeah, because that gets you to what you really want is the cosine of pi and the cosine.
Oh, that gets you to pi, and okay, I see.
Yeah, and a little awkward because of the shift, but that gives you the peaks. That's the furthest, right or left. I don't know which way they're calling right or left, but I guess that's right and that's left.
Okay.
All right, we'll have to stop here.
Yeah,
thanks so much for scheduling. I'll send you the note. Do you need the notes right away?
No, just later tonight if you can.
Okay, I'll do that, and then I'll see you tomorrow. Have a great night.
Thank you. You too.
Okay, bye now.
Okay.